So as this is Dr. Adam, so from the College of Computer Science and Information Technologies, so Imam Abdul Rahman bin Faisal University. I'm going to be talking to us this morning, introducing us to machine learning, especially looking at it as machine learning for improved healthcare delivery, taking clue from the past successful application while exploring the present and future possibilities. So you are all welcome to the class. I want to believe that there's going to be a presentation section, and after which there's going to be question and answer. So if there is any question that comes to your mind along the way, so try to jot it down so that you can then ask the question after the end of the lecture. We appreciate the effort of the organizers, the department, and we wish and pray that it's going to be beneficial to the participants and also the presenter, Bismillah. Now, so going forward, so let us look at these pictures, these two pictures. So as they say that pictures speak louder than maybe text. So we can see this is the state of technological development over time. This is said to be in 2009, and this is 2019. Just 10 years interval, you can see if you want to take a picture from the area, you see this is the risk that is involved. Someone has to practically comes out of the helicopter to take the video of the people downstairs to monitor events. But with a drone, no more risk of life, very easy, cheaper, safer, and so many other advantages. So this is the implication that the AI technology is taking the world like a storm. AI technologies and then ML, it's a special machine learning, is taking the world like a storm that is getting unstoppable. So, and the earlier someone key into this concept, the better before the person is left behind. Because imagine if this man still want to continue to work like this, I don't think no one is going to give him a contract to come and take a risk like this just because you want to take videos that might not even be clearer compared to what a drone will take without any risk. If the drone falls down, got destroyed, the video is already being streamed, live streamed to people, to other servers that are getting it recorded. So this is the huge improvement. This is just an hypothetical case of how AI has transformed everything you can imagine. Of course, it portends that this man might lose his job, but then he just needs to upgrade his skill to be able to know how to program a drone to take all these pictures while sitting comfortably in his office. So that is the revolution that artificial intelligence is bringing to the world. So a lot of advantages, of course, that are always the negative side of every invention. But with proactiveness, we can prevent ourselves from getting left behind by quickly upgrading, by getting to know what is artificial intelligence and how can I key into it, and how can I use it to improve or as an added advantage to my own profession. This time around, we're talking of public health. Now, so when we talk of that artificial intelligence, this is a kind of a very just overview. You can see this, the big guy here, the artificial intelligence, mimicking the intelligence or behavioral pattern of human or other living entity. You can see this drone is trying to do what this man used to do. This guy now, drone will do it smarter, better, safer, maybe faster. So we look at a lot of advantages. That is what AI is trying to do. Whatever human being can do, can we use AI to do it or to support the person? So it doesn't necessarily mean it's going to take the job, but the person needs to quickly welcome AI and try to see, okay, I cannot program AI. He can deploy his knowledge of cameraman into drone. because the knowledge will assist him to be able to be a very powerful programmer for drone in terms of image capturing from different angles and the case may be. Now, a subfield of artificial intelligence, because AI is made of several subfields. One of the subfields is known as machine learning. You see, which is a technique by which a computer can learn from data without using a complex set of different rules. See, it is based on training a model from the data set in what I usually refer to as let the data speak. This is the principle behind machine learning. Though it's not the only subfield or aspect of artificial intelligence, but today is the most vibrant fields of AI. Why? Because other fields, as you are going to see, you can see here, this is deep learning, this is machine learning, this is natural language processing, this is another artificial intelligence for processing natural languages, translating Arabic to English, recognize your voice like Alexa we do and some other applications, converting text to voice and so many other, summarizing text, cognitive, robotics, knowledge-based system, and also other systems. Prescriptive, big data, predictive, when they combine together with each of these, they generate powerful systems. However, why is machine learning so unique? It is so unique because today, if you don't have machine learning incorporated into NLP, your application in NLP will be very, very deficient. In robotics, without machine learning, robotics is going to be very peasant. It's going to be very low in terms of performance. So knowledge-based system, every other areas of artificial intelligence, they are incorporating machine learning into their system. So this is why machine learning is very, very unique as one of the fields of artificial intelligence. Because other artificial intelligence subfields also need machine learning to be able to take their own processing to the next level. I can't imagine having NLP without machine learning or robotics without machine learning, because that's going to make their performance or capability very low. So this is why machine learning is really very unique and important, and that is what we are going to be discussing much today. So under that, inside that machine learning, we have another special subfield of machine learning, which we call deep learning. We're going to talk about it later briefly. It's just a very small aspect of machine learning, which is very powerful when you are dealing with imaging, video processing, and text. It has unique capability to extract features from data without human intervention. This is what deep learning is really strong at. So you have text, you have image. If you want to use the classical machine learning for image processing, somebody needs to, first of all, extract the feature from the image or video. But with deep learning, we don't need human intervention. It has the capability to automatically extract the image features, and then the processing can continue. This is just at a broad. Now, moving on to that is just a preamble, our agenda for the day. We have a brief preamble, looking at a few quotations, brief introduction to machine learning. Then we look at successful application domain that we earlier explored, and our past successful application with just samples because of our time. Then we're going to look into application related to biomedicals and public health. We're going to look at samples, successful application here. Then we're going to talk about briefly ongoing efforts and the future possibilities. So challenges, future trends, and then conclusion. Now, we start by first of all looking at very few quotations about machine learning. The popular Bill Gates, the former chairman of Microsoft, said a breakthrough in machine learning will be worth 10 Microsofts. When you look at machine learning, the way it is really booming up, the potentials that it could offer. He summarized that it to be what 10 Microsoft. And you imagine what Microsoft was then. So it was a little bit maybe understatement. It is even what maybe thousands of Microsoft now, if not millions. The one machine learning is the hot new thing that also, of course, the one that is very, very important, that to me has summarized what machine learning has in stock for us, is this popular quote from the former director, Tony Tita, who was the director of DARPA at that point in time. He said, and I quote, "Machine learning is the next internet. Machine learning is the next internet." When you say machine learning is the next internet, what does it mean? When you say machine learning is the next internet, what does it mean? And anyone from the audience, you can raise up your hand for this question. Do you have an idea what it takes to say machine learning is the next internet? You can raise up your hands. If you have an idea, if you want to talk, what do you understand that machine learning is the next internet? We know internet, interconnection of networks. Okay, because of our time, I like having interactive class, so where people will talk, we communicate. But because of our time, so let's move on. I'll tell you the meaning. Machine learning is the next internet means that, as we know, the internet is a technology that revolutionized the way we do things. With internet, before, when you want to send email to your brother in maybe studying some another country outside the kingdom, you need to send letter through the post office. And it takes like how many days or weeks before you get the feedback. But today, if something happened here, so your brother outside, we may even get the information before you because of emails, WhatsApp, and so many other connections. This is made possible by the internet. Your banking today, you might not even go to bank in a year. Everything is done online. Why is it possible? Because of internet. Just log into your phone or to your computer through the internet. You can carry out any activity. Before, you used to go to bank to collect money or to deposit money. Today, you can deposit money anywhere. This is internet. It changed the way we do things practically. Things were ordinarily not possible to do or impossible before. All become very possible these days with internet. That was what internet brought to us. It changed everything. E-commerce. When I was an undergraduate studying computer science, we used to see e-commerce like theory. E-commerce, how are you going to sell things online? You see? E-commerce, what is going to be? We were learning the theory because it was not yet practical then. But today, everybody knows about e-commerce. Some of the biggest stores in the world today, they are online. Some of them don't even have physical stores. You see, everything you order online, they deliver to you. They have a way of doing that. These are made possible through the internet. In summary, internet changed the way we do things, making what we thought were not possible before becomes not just possible now, but easier. So if you can understand what internet has brought to us in terms of technological advancement and making things that were not possible now possible, then when you say machine learning is the next internet, it means the next technology that is going to change the world, that is going to revolutionize the world, that is going to change the way we do things, just like internet did, is going to be machine learning. And we're already there already. It's already around us. It's already within us. Anywhere you go, you hear of machine learning in the industry, in the universities, in any institution you talk about, machine learning. Even other parts, other subfield of AI that were in existence even before machine learning, they all need machine learning to be able to upscale. So this is what machine learning is about. I personally prepare this code is very, very instructive and very, very unique because it summarizes what you should expect from machine learning. That whenever you remember internet, the way it changes things, the next thing that is going to change the world in a revolutionary way, just like the internet, is going to be machine learning. And then there are other quotations from other people, but I see this as the most important quote of the time. Now, going to what is machine learning? I see machine learning is automating the automation. Automating the automation. Automation is the act of converting a manual process to a computerized process. For example, in the hospital, usually before we used to do everything, all the patient data they're on file, paper. But now we have the computerized system that doctors are being encouraged to put all the information into the system. Some people need to write a code and put that information into the system. That is what we call automation in computing. You convert manual processing into computerized process. Now, machine learning is now about this automation. We want to automate it again because usually human beings used to write code during the automation process. You need a software engineer to design, to automate your system for you. But now sometimes there are a lot of issues with software engineer development process, delay problems, and so many other challenges. Machine learning is trying to say, okay, can we take up this task of, instead of waiting for someone to write the code, can we just automate the process? Let something do it for us. This is the idea of machine learning. We want to automate the automation. So the act of developing, making something to be automated, we want to make it automatic again. It means we want machine to program themselves. In summary, to make it very clear, we want machine to write program for themselves. That's what machine learning is trying to do. Now, to do this, getting computers to program themselves. This is the idea. Automating the automation is getting computers to program themselves. So we don't want to depend on software engineers to do the programming. We want the system to do it itself. So writing software is the bottleneck. How are we going to achieve this? Because writing software is a big challenge. We call something software crisis, and that was what led to a course that we call software engineering. You see, there's a very popular course in computer science called software engineering. That is the art of trying to build software just like we build engineering structures. You know, before you build a house, you have to have a plan. We take a lot of time. You have to do the internal planning, the external planning, and also outline. So we say that software also cannot just be written quickly like that. Otherwise, it's not going to work. So they came up with software engineering that, okay, we can also build software just like we do in engineering systems. And there was a big conference then to discuss this concept. But still, even with software engineering, there's still a lot of issues when it comes to software development. That is why it's easier to get hardware product out quickly, but difficult to get software out. I will give a quick example for you to see. You go to the market today, you can see a laptop that is there was a time we were talking of Pentium 4 laptops. At a point we moved to Core 2 Duo, dual core, Core 2 Duo, dual core, the i3, i5, i7. We are talking of even multiprocessor these days now. So within a year, you can have 2 or more than 3 different type of hardware, new arrivals, new invention. But for software, it's not the case. For example, it took Microsoft how many years to move from Windows Me? For those who might know Windows Me, it was an edition of Windows. Microsoft took how many years to move from Windows Me to Windows Vista? See, this is a very powerful software house. After building this software, taking several months or years, they release it for people. But after the release, they notice that there are a lot of bugs, a lot of problems with the software. that software had to offer everybody who purchased Vista was granted the opportunity to move freely to the next edition of Windows. You see, it was Windows 7 then. Because they noticed that a lot of bugs, lot of problems with the Vista, even though it took them several years to release it. Yet they found out that a lot of issues. So it means software development is a very challenging thing. Even the most powerful software houses cannot guarantee that they're going to get it right. Therefore, we need a better system, a better way to get this thing done. So how are we going to make computers to program themselves? Software engineering tried it in the past, but it was not a big success. You see, that if you can write software requirements in a very formal way, we call it formal method, then you can automatically convert it to software. It didn't survive. But today, machine learning is saying all these stories, we can just solve the problem by let the data do the work instead. That with data sets, we can actually write that program automatically. Wow. Really? That is what machine learning is saying and is trying to do. That we don't need to waste so much time writing program. Let us get data. The data will tell us how we are going to deal with the data. And that's why we say, let the data speak. And that is the big stuff that machine learning is bringing to the table. Now, let's see how it works. I said, this is a big paradigm shift. A big paradigm shift called let the data speak. Traditional programming, the idea is this. You need someone, a software engineer, to write a program for you. Then you provide the data and it generates an output for you. This is what we used to do. And I've explained to you there are a lot of challenges with this approach. Even the best of software houses has issues. Delivering software as at when due. Now, machine learning is saying we don't need to pass through that. Give me the data and give me the outputs. I'm going to generate a program for you. Can you see the changes? It's a total revolution. So we don't need to wait for a software engineer to come and write the program for us. Computer will write it by itself by using data and the output of the data. This is wonderful. The good news is data is always available. Go to the clinic, go to everywhere there's data wasting away in our offices. Can we just gather this data? And then we have the output. You go to the clinic. So we have a lot of data set there. How many thousands or millions of diabetes patients that have been treated in our teaching hospital? Can we get their data set? If you can get such data set, okay, this patient number one, maybe diagnosed in 2018 or something like that, we confirm his diabetes. Give us the attributes of this patient, the age, the weight, and some other clinical features or clinical attributes of this patient. Give us so many patients. This is the output. The output is it diabetes? No. We have another patient that is not diabetes. Another patient that is diabetes. Give us all these. So this is the data. And then this is the output. We give the data, which are the attributes of our samples. And then the output is, we give this data to the computer. Hey, this patient coming in is diabetes. It's one. Yes. Study the attribute, the age, the family history, the weight, the BMI score, and so many other medical terms that you do measure for your patient. The computer should try to study it. What is in the attribute of this patient that is making him or her to be diabetes? Then we have another patient next. Take him in. He is not diabetes. The computer will try to study what is in this patient number two that is making him not to be diabetes. Is it the age different? Is it the BMI? Is it the historical data? Maybe the father was not diabetes. That is why he's not diabetes. Because sometimes you see the same patient, the same weight, but one of them is diabetes, the other one is not diabetes. Maybe because the father of one is diabetes and the father of the other one is not diabetes. So machine learning will try to study all this relationship and come up with the final program which we call the hypothesis function. Hypothesis function. Hypothesis function. So practically, this is what we call the learning process. Learning, and that's where machine learning comes from. So computer is trying to learn what is in data one that is making this patient to be diabetes, but the second patient is not diabetes, the third one is diabetes, the fourth one is not diabetes, like that. So we have so much data. Just imagine how many data we can get from our university teaching hospital. So when you have this big data, we train our model to be able to recognize if someone is diabetes or not. So at a point in time, anybody can just check himself with that system to know that he is diabetes or not. This is the shift in paradigms that machine learning comes to play. So there's no one to write a program for it now. However, computer being just empty, it needs some algorithm. There's something we call algorithm, machine learning algorithm, that will guide the computer how to do the learning, how to train itself. We have k-nearest neighbor, we have decision tree, we have support vector machine. These are just algorithms. You are not writing program like this one, no. But algorithm to tell the computer how to learn, and different algorithm with different capability. Once it is guided on how to learn, then it generates a program for us, which is the output of the training process. And then we call this one model. Machine learning model has been built. Algorithm plus adequate data and the output of the data will generate what we call a program or model or hypothesis function, as the case may be. So this is what we call a paradigm shift, and that is what machine learning is here to stay. How does it happen? Machine learning just give data and output, and then it just generate a program like that? I say yes. So software engineer here, I used to advise people who are in software engineering field, you need to start updating yourself to become machine learning engineer, because these algorithms need to be written by some people. You see, we need a lot of new algorithms that will guide the computer on how to train itself. So this is where someone who is a software engineer need to be upscaling the task to become machine learning engineer, so that you still need to be, as a matter of fact, with time, programmers are going to be losing their job to AI. So they also need to upgrade their own skill to become AI programmers. And that is the reality. Now, how does it happen? We say it's not, is it magic? No, it's not a magic. Just data and output, and you generate a program? Yes. It is just like a gardening. You know, maybe you have a garden beside your house on your farm. See, the seed is the algorithm. The seed is the algorithm. You plant a seed, you put it under the soil, and you cover it, and then you put water, or the rain falls, the kudratila, it started coming out. So the nutrient is the data. Sometimes you put some fertilizer, like animal dungs or animal waste, you put it there. That is the nutrient, and that is the data. You see, if you don't put adequate number of data set, it will not work. You see, if you put a bad nutrient in your plant, or the soil is very, very damaged, there's no nutrient, even if the plant germinates, it will not survive. If it survives, it will not produce good fruit. So you need enough, adequate, sizable, and the appropriate data. And that is the nutrient. Of course, we have the gardener, and that is you, the machine learning expert now. You are the machine learning expert that will decide what is the appropriate algorithm to use. What is the data that is good? Sometimes the data we get from clinic or from the companies is not clean. The data is bad. So we need to make it better. We do a lot of pre-processing for this. Just like if your nutrient is not good, your fertilizer is not good, you need to make sure you change it or you buy another one. So you are very important there. The gardener, you are the one, this is the gardener, you are the one supervising it, making sure everything is in order. See? And then the final output is going to be the plant. You know, after you make all this effort, you go to your garden or to your farm, then you find that There are a lot of very nice green vegetation. Look at it, very, very nice to see. That is the outcome of all your labor, seeds, nutrient, and you as the gardener, you are going to produce plant, which is the program in this case. So it's not a magic, but a carefully thought out process, and that is what we call machine learning process. Now, moving forward then, we said, what is machine learning? We said learning is any process by which a system improves performance from experience. You see, the data we're talking about is previous data. You get old data. We use it to train our system. Then we can extrapolate it to functional. As we're going to see in some of the applications we're going to be demonstrating for us briefly, inshallah. So machine learning is the study of algorithms that improve their performance P at some task T with experience E. Another way to look at it. So you can see, so the machine learning always the algorithm try to improve their performance by if you get more data at a particular task T. Of course, in artificial intelligence, you don't have a system that solves all problems. This is one of the reality and the attribute of AI. AI don't solve all problems. A single AI, you have to develop AI for different problems you want to solve. For example, you have to build a machine learning model to predict if somebody is diabetic. You have to do another one if somebody is hypertensive. You have to do another one to know if somebody is having heart disease. That is why we say at some task T. You see, you don't have one solution fits all. It doesn't happen that way. So you develop it for each task or each field as the case may be. So we said the goal of machine learning is to build computer systems that can adapt and learn from their experience. So, and machine learning discovered the relationship between the variables of a system, very important. It discovered the relationship between the variables of the system. What are the variables of a system? We have the input, then we have the output. In between the two, there is the hidden relationship between them from direct samples of the system. Every system in the world falls into this category. You're going to have the input and you have the output. But between the two of them, you have a linking relationship, which we don't know. So machine learning has that capability to detect that relationship. Why is this patient? Why is he diabetes? Why is patient 2 non-diabetes? Why is patient 3 non-diabetes? And patient number 4 is diabetes. Sometimes you have a junior brother that is diabetes and the senior brother is not diabetes. Why? So machine learning has that capability to reveal the hidden relationship between these two systems, input and the output. And this is a generic system looks like this. We have the input variables and we have the hidden variables. See, and then the output. Between the output, you can see this is the input, the attribute, the clinical data of your patient, and this is the decision of previous doctor who treated them. This one is diabetes, this one is not diabetes, this one, and host of others. And host of others. Now, so this one is diabetes, no, it's not diabetes. You need a system which is hidden. You see, and you need the machine learning to determine the hidden information. What is the hidden variable? We call it H, or hypothesis function, that is linking the input to the outputs. And this is the secret that machine learning has the capability to detect using different algorithms that have been developed for machine learning. So quickly, we look at machine learning paradigms. There are different subfields of machine learning or different ways of implementing machine learning, as the case may be. So the first one is one we call the association. See, the association. In the association, sorry, just a minute. Excuse me. Now, so we have the association. This is where a special type of machine learning or a subfield of machine learning whereby we develop a system using probability principles, for example, to check, for example, what is the probability that somebody who buys X also buys Y, where X and Y are products. We call the example is basket analysis. You see? So when you go to shopping mall, there are a lot of machine learning machine learning system that has been developed, models, that looks at the purchasing power, the purchasing styles of every visitor. So they want to know what is the probability that the person who purchased chips will also buy biscuit. You see, probability that person who bought biscuit will buy chips is 0.7. It means very high. So they tried to have a system like we call it association rule mining. Association rule mining. A very popular example I'm going to give is the basket analysis. When you go to shopping malls, sometimes you see the shopping malls, they rearrange their system, their shop on regular basis. Where they used to put laptop, they put it in another place. They did a lot of rearrangement that sometimes you find it difficult to locate what you used to buy before. Why do we think they are doing it? They don't just do it randomly, but the onset of machine learning has made them more possible for them to know which product people are likely going to buy together. So when they notice that, a lot of people, whenever they buy a laptop, for example, they notice that if let's use the very simple method, what we buy every day, they notice that anybody who buys baby food, they usually buy together Pampers or any other diaper family. The next rearrangement they are going to make, they make sure that baby food might be at the beginning of the mall, it's going to be here. They will separate the item B, let's call it now item A and item B. If they notice that people always buy it together, anyone that buys A always buy B in our last analysis. The next time they're going to put A, other material, other products, they make sure that B is far away from A. You see? So that when you buy A, you need to look for B because you always need it. They notice this is your pattern of purchase. So you have to start looking for it. So in the course of looking for it, you can see other products that are on display. It's a form of advertisement. You see? They take advantage of you. They know that our customers, anybody that purchases A, will always purchase B. So they separate them. You hardly get them together. So while you are trying to look for the item B, you keep seeing other things. Even if you are disciplined, you don't want to buy what you don't need. Your kids are with you, families are with you. They ended up picking things. And before you know what is happening, your shopping cart is full before you get item B. That is the power of machine learning for the business community. Of course, people say this is manipulation. Of course, yes, I say there are some other positive and negative aspects of every system. So finally, whenever they know that there's an item number C, item C, no one purchased this item and it goes for like maybe 10 real. But item A usually goes for maybe like 30 real normally. So this is item C is not being purchased. No one is looking for it. Next time they're going to do promotion for you, they say buy A and get C for free. Buy item A and get C for free, and then the price is going to be 25 real. You know, this used to be 30. Sorry, it's going to be 35 real. 35 real. So you're going to say, oh, this used to be 10 real. This used to be 30 real. I'm going to buy it two for 35. I'm saving 5 real. Yes, you are saving 5 real, but you are buying what you don't need. That is the power of basket analysis. And that's one of the examples of machine learning application that are often used in the business community. The second type is supervised learning. This is why I said this is where we are. Majority of applications are here. Majority of applications, they're always here. Yeah. So majority of applications are always here. So under supervised learning, this is when you learn under the supervision of a teacher. And all the examples I'll be giving this morning, they fall under this, where you have data and you have the output. This is called supervised learning, because we are supervising our computer by providing output for it. Patient 1, this is the output. Patient 2, this is the output. This is called supervised learning. So, and it's a very, very popular and very common machine learning application. So it's divided into two types. We have the classification and we have regression. The only difference is in the output. If the input is yes or no, that is classification problem. But if the output is yes or no, the input can be the same thing. That's okay. But the output, if it is yes or no, that is classification. But if it is a value like 32.5, 16, 61, this is called regression. See, for example, here, if I want to predict if a patient is going to die from a surgery or not, that is a classification problem. So the output is yes or no. If I want to predict if somebody is diabetes or not, that is yes or no. Anything like that is known as classification problem. But sometimes I want to predict how long will this patient live before he possibly die. Wallahu alam, that is regression. I mean, you are going to predict value 2.5 months, 3.5 months, or 3.7 years, or 16 years, 0.5, as the case may be. I want to predict what is the age of a student. You see, this is regression problem. I want to predict if a student will pass an exam. That is yes or no. That is classification. I want to predict what is going to be the final mark of that student. Is it 92, 93, or 94? That is going to be a regression problem. So regression and classification only differ based on the type of output they have. And the good news is the same algorithm that you use to solve classification can also be modified to solve regression. Now, the next is unsupervised learning. In the unsupervised learning, this is where you have data, but we don't have the output. We have data, we don't have output. The output is missing. So there is algorithm that will try to still understand the data. We know this data is for diabetes people and non-diabetes people. So, but we don't know which one is diabetes, which one is not diabetes. So we give it to the system. The system will try to understand it. It will try to cluster them randomly. I think this guy, this one is diabetes, this one is diabetes. It will run the experiment again and notice that this one is closer to this one. He put this one back to his friend. He keeps changing, and finally you are going to have group together. Okay, these are diabetes, this one are not diabetes, without any supervision. This is called unsupervised learning. It is tough because sometimes you cannot guarantee excellent results, but sometimes we use it when we don't have option. In fact, we don't pray to have it, by the way. We only pray to have the supervised learning because we have enough training to be able to give to our system and we can get better results. But unsupervised learning, when our client contacts us and say, hey, we want to build machine learning model, however, we don't have the output. Wow, that's going to be tough, but then we will try. We're going to use unsupervised learning. They'll try to look into the data and try to classify them into different groups. So because of our time, more details of this, so we're going to give us a reference that we can also, we can always refer to some of our videos that we have that has explained these things in details. Semi-supervised learning, this is when you have a kind of, there are some outputs and there are some samples are having output while some are not having output. So this one, no, there's no output. We don't have output. Output missing. This one, there's output. We have output. But for this one, there are some outputs and some output also missing. So we have a mix of it. Then we use semi-supervised learning. It's in between supervised and unsupervised. Sometimes we call it active learning, like interactive supervised learning, as the case may be. So you have a mix of small labeled data with large unlabeled data. So very few data sets are labeled, while majority are not labeled. So we're going to use semi-supervised learning. Then we have the reinforcement learning, which is learning a policy using a sequence of outputs. They are used for training a lot of agents, artificial intelligence agents. You see, it's like we have a policy like negative, positive, punishment, and extinction. It's practically learned from mistakes. It learned to react to the environment. For example, even in human being, we have it. If a child does something good at home, the father wants to give her chocolate so that he or she can continue to do the same good act. You see, this is called positive. You encourage them to continue. Oh, good child. I give you special chocolate. That is reinforcement learning. You are reinforcing that child to continue to do the good work. However, if he does something that is not good, you corrected him or her. Next time he does it again, then you can go to negative. It means you don't give chocolate. Rather, okay, the chocolate I wanted to give you, I'm not going to give you. Then you always remember that, oh, so I'm not going to get chocolate because I didn't do what my father asked me to do. Okay, so next time you will not do that. That's reinforcement learning. You see, you have a policy to compensate or to punish. Sometimes we have punishment. It's not just that you are going to withdraw something. You actually give a punishment for that person for doing what he's not supposed to do. And we have extinction. Sometimes we take away the system totally. An agent that continue to violate the rules of AI agent in an environment, like robot that's not doing what it's supposed to do, we take it all away. So this is called reinforcement learning. So these are the different categories of machine learning. However, the next one is deep learning. I put it here, even though it's under machine learning, but we will not consider them like similar to this one. Deep learning is a totally special area of machine learning that is I call it a special subfield of machine learning with exceptional capability to handle features extraction automatically. You see, when you have imaging, video, and text-based processing, deep learning is very powerful in this system. It has its own way. It's wired just like our brain works. It thinks deeply, just like we sometimes think deeply. It's totally in a way, although machine learning also try to emulate human brain a little bit, but deep learning takes it to the very deep level. The way human beings think deeply, deep learning trying to solve this problem like this. So that's why he had the capability to do what ordinary classical machine learning cannot do. So, however, it's very, very powerful. I've seen people make mistakes whenever they have a problem to solve, they go for deep learning. No, you need to know when to use deep learning and when to use the other classical machine learning algorithms. If you have a text file, for example, you got data from the clinic that has the clinical information of patient, and then they had output. Maybe this patient is having hypertension or no hypertension. This is just a text file. You go ahead and use classical machine learning, which solve the problem for you. You see, you don't need to do deep learning for everything. I've seen people do deep learning for very simple text classification. Deep learning got very low accuracy of 85%. We use k-nearest neighbor. K-nearest neighbor is a very simple machine learning algorithm. Show me your friend, I tell you the kind of person you are. You look at the neighbor and see how the neighbors are performing and classify based on that. Using simple k-nearest neighbor, we were able to get at the start 95% accuracy, something that deep learning got stuck at 85 because we were using it for a wrong solution or for a wrong problem. So, but when you have problem like image processing, video processing, or text processing, in order to avoid human intervention, because the strong part of deep learning is it has the capability to extract the feature by itself. It doesn't need human intervention in this sense. But once it extracts the features, we can actually use the feature to train other machine learning algorithms and then compare it with deep learning itself and see which one is going to work better for us. Because there's always a policy. Let the let the data speak. That is, the data will determine which kind of machine learning type you are going to use. Now, so moving forward, we have said earlier, this is the category of artificial intelligence. We have the machine learning, and then we have the deep learning here. This is how you can visualize them. So this big guy, NLP is there, robotics are there. There are so many AI stuffs, but then this is machine learning here. Or inside machine learning, you have deep learning. So how we grasp the difference between them. Now, we quickly look at some of the algorithms and techniques that we often deploy in our researches. We have different algorithms. They both support classical supervised learning and unsupervised learning. So mostly they are supervised learning. Like I said, we always pray to have supervised learning problem, because unsupervised learning, sometimes you cannot guarantee it's going to, actually it's an abnormality because the output is missing. You see, in most cases, it's an abnormality because the output is missing. So we just try to do something, but we always try to get data that has output so that we can do supervised learning. You can see these are some algorithms like artificial neural network, decision tree, k-nearest neighbor, support vector machine, extreme learning machine, sensitive based learning machine, type 2 and type 1 fuzzy logic system, deep learning techniques, hybrid machine learning techniques. Sometimes we do an ensemble machine learning. We do mushakal of different algorithms, because sometimes you have data set that is really tough. You use all the algorithms you know, it doesn't work. Then we start combining them. You put algorithm 1 and 2 together to solve one problem, and sometimes we get better results. This is called hybrid learning and also ensemble learning. So for some of these details, like I said, we're going to provide a link for us that we can learn furthermore about those ideas. Also, sometimes also we have optimization techniques to optimize our hyperparameter. There are some parameters that affect the performance of our algorithm. We need to optimize it to look for the best value for them. So sometimes we do it manually, searching for the best parameter. Like k-nearest neighbor now, we need to search for the number of neighbor k. Is it 1 neighbor or 2 neighbor or 3 neighbor or 4 neighbor? We have to try several ones before we get the best value of k, and then the Euclidean distance, and then the distance measure. So sometimes we don't want to do it manually. We want to use genetic algorithms to search for the hyperparameter, gravitational search algorithm, particle swarm optimization. When you see etc., it means there are so many optimization algorithms we can use. And some of the successful application area by our teams include, but not limited to that. This machine learning we just introduced to you, you can use it in diverse areas. We've often used it in oil and gas for permeability prediction, PVT property of oil and gas, nanomaterial characterization, magnetic refrigeration, material science, and most important to us today is medical, biomedical, and public health predictive solutions and applications. We do a lot of this. You can also use it for a lot of this to solve your problems. Superconductivity, membrane technology, cybersecurity, etc. So many areas. Like I said, it's like internet that is going to revolutionize the world. Machine learning is everywhere. Wherever you can get data, you can use machine learning. Other significant useful application, ignition energy prediction, explosive temperature estimation, and host of other. So today we are more concerned with this, which is medical, biomedical, public health. So let's see some of our recent application outputs or outcome of some of our research related to your public health, so that possibly you can take a clue. You can take a little bit of knowledge and motivation on how you can solve your problem there. So let's look at the public health debacle here. Application related to biomedicals and public health. Look at one of our recently published work. It's called Novel Ensemble-Based Techniques for the Preemptive Diagnosis of Rheumatoid Arthritis in the Eastern Province of Saudi Arabia. This uses clinical data, just clinical data. Yeah, not imaging. Because sometimes before you can visualize a disease in the body of a patient through image, the disease already at very late stage or mature stage. But the idea of this is preemptive diagnosis. We want to preemptively diagnose. This is the idea, preemptive diagnosis. Before somebody falls sick, you see, before someone even has any symptom of sickness, we want to predict that this person is having the disease already. Because people just go to clinic for a minor pain, complain, and by the time they check, they say, oh, we are sorry, this is a late stage disease. Why do we need to wait for late stage? This is one of the motivation for this work. Why do we wait for people to be sick critically? Because by the time they complain, it means the organ is already now feeling the pain. The disease is already in the body long time ago. So the idea is we want to get it at very early stage before the pain starts. And medically, you know better. It is always better to get early treatment in order to be able to solve a problem. So another one also published not long ago is another preemptive diagnosis of Alzheimer's disease. Preemptively, before the disease actually starts symptomatically, we want to identify that this person needs to check himself up as soon as possible so that the decision could be taken to avoid the complication. Another one also, not long ago, we published this together with some of the faculty from College of Public Health, actually. So it's a prediction of generalized anxiety levels during COVID-19 pandemic, a machine learning-based modeling approach. So telling us the several areas you can check out. If you can get data set, then machine learning can solve the problem for you. Then another way is comorbidities and risk factors for severe outcomes in COVID-19 patients in Saudi Arabia is retrospective cohort study, also published some time ago. And then the Google trend identifies system of religious gathering applied to investigate correlation between crowding and flows. Support vector regression modeling of myographic signal predict muscular simulation evoke knee torque in paralyzed quadriceps muscle undergoing knee extension exercise. This is for people that do post-treatment training for the patient to come back to life properly in terms of maybe there was an accident that injured the leg. We need to train. They need to do physiotherapy. We actually develop a machine learning system that can support them in solving such a problem. Other applications related to biomedical that have been done, so many of them. This one is all about, you can see here, we use neural network and support vector machine to predict chronic kidney disease. See? So chronic kidney disease could be predicted using just basic clinical data. In this one here, we use genetic algorithm support vector machine in biomedicine. That is, what do we do here? We estimated the refractive index of oxygenated and deoxygenated hemoglobin. You see, we want to know the refractive index of oxygenated and deoxygenated hemoglobin. You know about this. We deploy machine learning. You can see the output because we were predicting point for point. You can see here it's showing the prediction is on top of the original value, which showed excellent predictive capability. So other applications also include refractive index prediction for hemoglobin using the hybrid GASVM. And then we have classification of Parkinson's diseases using the NNGE classification algorithm. We all know about Parkinson's disease. The system was done to predict achieving the maximum possibility of 96% accuracy using AdaBoost and Symbol as the best system of that. We also had in the past preemptive diagnosis of diabetes mellitus using machine learning. So machine learning was used to predict if someone is going to have diabetes preemptively. We don't wait for the symptom. We don't wait for the organs to be destroyed before it happens. Because we've had cases of people who just went blind. They never complained they were having some signs. They never knew. They used to go to washroom in the night very repeatedly, but they never dared to check themselves. Maybe because they were busy. So having a preemptive diagnosis system will prevent such a situation so that we can quickly diagnose and offer remedies. We also have preemptive diagnosis of schizophrenia disease using computational intelligence. So we've also worked on preemptive diagnosis of chronic kidney disease using the machine learning that was presented in the conference paper. We also had a prediction aided model that is for post-operative decision making based on neural network. This is a very, very interesting work. When doctor goes to the surgery room, they need to monitor the patient to take decision after the surgery. Should I put him to go home? Should I release him to go home? I should put him in the ward, or should I put him in ICU? You see, the best thing for every doctor is to put a patient in ICU to be on the safer side so that there's no complication unexpectedly. But that ICU is usually limited in capacity. So they have to put some people in the ward, some has to be released to go home. But imagine a medical doctor that has been on operation for several hours and he still has to sit down and analyze the data that the machine that is connected to the patient has been recording for how many hours. We're saying we can use machine learning to support them. So that machine learning will study the data set of the patient in the past. Patient with these attributes, with these clinical characteristics, what was the best decision taken for them? So we can predict for them, okay, take him to the ward, take him to ICU, or let him go home. This is another area. I said it's to support medical doctors and the health practitioners. So we also have where we use investigating the effect of correlation-based feature selection on the breast cancer diagnosis. So was also done with very high accuracy of 97. We've also had to use computational intelligence-based model for diarrhea prediction using demographic health survey data. You see, we want to predict the onset of some infectious diseases that can spread quickly. Can we predict when it's likely going to happen so that we can take precaution and allocate things appropriately? And then also another one again in the role of trying the intercept was another one following the previous one, whereby we actually use support vector to predict the Toku invoke NIC from a particular earlier injured patient, as the case may be. And then we also did what we call breast cancer surgery survivability prediction. Somebody want to go for breast cancer surgery, we want to predict if the patient is going to survive or not. Because there are a lot of data set in the past that can be used to take this decision. So it will assist doctor to take decision appropriately or as the case may be. And the fact that we predict that someone might not survive, it doesn't mean he's not going to survive. It means doctors need to make sure a lot of emergency system are put in place in case something goes wrong. There's not going to be a case, we are looking for somebody, we are looking for something. No, machine learning already predicted that this patient might not survive. So you have to go to that surgery with a lot of preparation, with every emergency support available to prevent that prediction from coming to reality. That is the essence of this kind of surgery, and this kind of study and research. And because of time, we have so many other areas we have actually deployed in biomedical, ongoing efforts and future possibilities now. Say preemptive diagnosis of liver cancer, hypertension, they are all on the horizon. Works are going on. Asthma, thyroid cancer, schizophrenia, as early warning system towards sustainable proactive medicine in Kingdom of Saudi Arabia. We're predicting that we want to have a preemptive diagnosis to serve as an early warning system. We don't want people to fall sick before we give them warning that they might be sick, because there are already some attributes in the blood that indicated that this person is having attribute of people who had diabetes. But often than not, we miss it until they come to clinic to complain. And by the time they complain, maybe it is getting late. So we want to get it earlier so that we can offer preventive measures to prevent him from coming full-blown diabetes or hypertension or any disease. So we're doing that also for cervical cancer. Also one we call it computational intelligence predictive model for flu incidents in Eastern province of Saudi Arabia. We are working towards improved biosurveillance. Biosurveillance is we keep looking for the atmosphere when there's likely going to be a flu, because there are a lot of signs in the atmosphere when there's going to be outbreak of flu or any disease, but we don't monitor them. Presently, we have a predictive system for rain. Few days ago, some days ago, the civil defense announced there's going to be rain in Eastern Province, and there was rain. Bikudratullah. So because there are some signs on the sea, the wave, the air quality that will indicate there might be rain, so they make prediction. But sometimes it doesn't come, sometimes it comes. See, we have predictive accuracy. So in this same way, if we can predict there's going to be rain, then we should be able to also estimate when there's likely going to be outbreak of flu, so that people can take precaution. Okay, next weekend there might be outbreak of flu. If you're going to take your kids to the park, make sure they use mask. Otherwise, you get the emergency fill up those kind of times. This is called biosurveillance. We monitor the environment for possible disease outbreak. But this area is not yet well used, even globally. So this is a very hot area that people who are interested in this area can focus more on. Finally, towards the end of the class, we say a further shift in paradigms, so that data may speak more clearly. So in this case, we propose hybrid and ensemble systems. We want to mix models together. We have model 1, model 2 can combine to form combiner 1. This one also comes, several ones, they also, finally, you have the final combination here. We do muchakel, mixture, cocktails of ensemble. See, this is an algorithm plus data called model. Because when you add algorithm from data, plus data, it forms model, model 2, model 3. So we mix them together like a cocktail. They give us final result, and it has always been proven that ensemble model perform better than individual model. That's the next thing that people are shifting to, as the case may be. So we discuss a lot of things. The next thing I know that comes to your mind as students or participants is, how do we implement these systems? It is very simple. Very simple. You see, you can have it in Python if you know how to program. A lot of Anaconda is there, NumPy is there, R programming is there. Even my friend is also there, MATLAB. MATLAB is another powerful way. We used to model before. You see, Orange is there. Weka is also there. See, which one you like? However, I have a good news for people who are not computer science professional. Because people do run away. Hey, I don't know programming. I have good news for you that you don't need to be a programmer to use machine learning, to build models in machine learning. To use ML, you don't need to be a programmer. No. In fact, there's a new aspect of AI that has been launched, promoted, even by Harvard University and top researcher worldwide. And that has been my own idea about machine learning. That machine learning should be for everybody, not only for computer science people. We call it codeless AI. Codeless AI. Codeless means you can do AI without coding. You don't have to be a programmer to use AI, to build a model, to deploy a model. You have your data from your clinic, you can plug it in, you can use it easily. And you can generate your model and use it to predict for your next patient. Very easy, very straightforward. One of it is you can use Weka. Weka is very simple, free software that within a few minutes you can learn it and start deploying models. And it's acceptable anywhere in the world. You can use it to publish your research outcomes. So that's why I say I have a good news for you, because people always say, oh, I would have loved to do this, but I don't know how to program. You don't need to know how to program to build machine learning models. That is the good news I say I have for you. Of course, if you know programming, that is excellent. Then you can go for any programming language you like, because machine learning is independent of the platform. Some people use MATLAB. Some people use Python. Some people use R, while some people use Java. A lot of programming, C#, C++. So that's why I'm not really particular about any platform. And you don't know how to program, it's okay. You go for codeless AI. You go to things like Weka, even Orange. You can use it without a code. Just drag and drop. Click this button, get your data inside, click the necessary button, then you get your work done. Really? Yeah, it's as simple as that. So hope that is going to motivate all you all to try to see how you can put your own hand on developing solutions for your own area of interest. And then announce this opportunity for you, that for people who might be interested in taking it further. I say opportunity to learn machine learning modeling for real life problem solving using codeless AI approaches. So there's this free weekly machine learning seminar. So you can join us. It's 9:30 to 10:30 Saudi Arabia time every Saturday. It's a free class to take machine learning to the people, to let them take advantage of this very nice technology so that we can improve the health of the people in the kingdom by deploying appropriate medical facilities, by appropriate machine learning solutions, and also the world over also can benefit. So for those who want to take it further, you're welcome. You can join us using this link on a weekly basis. And then you can also join, you can also check out our video. This lecture has been personally taken by myself. You can check out our YouTube video with several of 24 hours. You can always check it out and see some of this concept. I just have to summarize in 1.5, maybe 1.5 hours, or the case may be. There are so many other things we need to learn together. So you are free to contact if you need any clarification, especially if you are interested in taking it further from here. Challenges. Everything, no matter how sweet, how good it is, there are always challenges. One, heterogeneous nature of patient health care record in format and location. We have this challenge of heterogeneous nature of patient health care data. You know, some data set are in image, some are in the video, some are in maybe X-ray format, some are in text, and so many other format, you know. So presently, we use only clinical data because we believe that since we are dealing with preemptive diagnosis, anything that enters the body will first appear in the blood before it becomes apparent in the face of the patient. It will spend some time in the blood. However, it would be great to have a system that can combine imaging, clinical data, text data, and everything together into a single model. But it's very challenging. So people are working on this, and we hope one time we'll be able to have an ensemble that could merge everything together. Health data privacy. We can use high performance computing to solve this problem. Because if you want to do that, you're going to have a huge computational complexity. Health data privacy. You know, the issue of health data privacy is an issue. We find it difficult sometimes to get the data set we need to deploy our model. So this is an issue in medical. However, the good news is we need to educate ourselves is in machine learning prediction, we don't need the patient details, by the way. You see, we need anonymized data. We call something anonymized data. Data said that you cannot trace out the patient that owns the data. I think we can make our data available even online for people to be able to do research, as we have in also some other institutions all over the world. I mean, the idea is patient record should be removed, and name should be removed. Anything that can identify the patient should be removed. We have an anonymized data. Data said that no one can trace where it is coming from. So we can make data available for people because we don't need to know the patient to build machine learning. So hopefully this idea will make it easy for people to access patient data without the challenges we are currently facing. Understanding cooperation issue between the health professionals and the machine learning researcher. So sometimes machine learning procedure need to shake tables. That is, explore strange procedure different from what are well established in the health professions. Sometimes machine learning need to try some things that are strange to our partners in the health profession. Yeah, because for example, I want the data set to predict if a patient is having a particular disease, maybe hypertension. You know, some of the biomarkers or the markers you use to check. But machine learning says, let us have all the data set. Let's check everything. The principle of let the data speak. Maybe we have some concept we have been checking in the past, but now things have changed. The food we are eating is different. You see, the children mode of life is totally different. Some of them stay overnight without sleeping. They have access to watching films that affect their brain, their cognitive level. So some of those methods we were using in the past, we need to use artificial intelligence to check further. Maybe changes in the pattern of our life has also affected some of those factors. So that's why in machine learning, we try to have all the data set. We are not opposed to add professional opinion, but we say also sometimes we need to check outside the box. This is what we call think outside the box. Let machine learning look at the old data, not a restrictive data. Okay, for you to do diabetes prediction, you need 3 tests. This. Machine learning say, okay, thank you, but please, can I have more tests? Because we want to check it. And we have deployed this concept in oil and gas, where people know that A, B, C, D are very important in the prediction of a drilling system. So they have been using A and B. They say C and D is not very important. But on further investigation using machine learning, we came to know that actually D plus B offer best combination. And the engineers with their huge number of years of experience, they have missed that opportunity. So this is where I say that machine learning can support us to make even our better decision, as the case may be. And finally, lack of enough AI machine learning professionals. There is still a lot of demand. We have so many ideas, but there's no time, there's no people to implement them. So many ideas. And it's all over the world. It's not only here. Go everywhere you see people, machine learning engineers are being demanded here and there, because people are not available to do that, because a lot of industry are taking over the few people that are available. They are going to the industry, and other companies, universities, hospitals, they are struggling to get their needed AI machine learning professional. Of course, the good news is you and me and everybody listening to this lecture can become an AI engineer or professional, especially with the coming of codeless AI, whereby you can also build the model for your institution, for your department, without the need for you to write code. So finally, future trend, we're looking at the possibility of using ensemble and hybrid model proliferation towards improved machine learning predictive solution. So if you can do cocktails of several algorithms, we might be able to improve the accuracy of our systems, especially with high performance computer now everywhere. So the issue of computational complexity might not be a problem. Representation learning, that is the continued rise of deep learning approaches, especially for image-oriented solutions, is very encouraging. Need for unified healthcare data analysis framework, irrespective of the format, either MRI, CT scan, and those, can we combine them together to get unique model through ensemble? And of course, the future trend is codeless AI, which is implementing AI solution without coding. If you don't know programming, you don't need to run away from machine learning. You are highly welcome, as that is the next thing. This is the present technology. It's no more the next technology that is revolutionizing the world, just like the way internet actually did. Ethical usage emphasized. For me, I want you to know that machine learning is incredibly powerful and can be significant. Sometimes it could be unintendedly used negatively, and it could have negative consequences on society through targeting, excluding, and misusing. So my own advice is focus should be on the beneficial aspects while avoiding the negative usage. And this is what I personally call ethical predictive solutions. And I promote ethical machine learning solution as a person. So we look at where we can make life easy, we can prevent problem from going worse and quickly solving the problem. These are the positive aspects of machine learning we promote, because any system can be misused, but we promote and emphasize on the positive and the ethical usage of any technology. So for further details, you can see some of our related works. The Google Scholar is there, my ResearchGate, also my machine learning training YouTube channel. You can check it out. And my contact is there. So this is what we're going to have for the day. We're going to give room for questions. That is all for now. If we all do a little, we will do a lot. Thank you very much. wa sallallahu ala sayyidina Muhammad wa alihi wa sahbihi ajma'in. Assalamu alaikum wa rahmatullahi wa barakatuh.